Okay, hey, my name's Rick Patton, and I am putting on a webinar today called IoT in the Cloud. Last time I did this, which was about 2 hours ago, and I muffed it, I forgot to ask the polling questions. Okay, so these questions, I believe, are intended to be answered by the attendees, for the monitor, the class monitor, to ensure that everybody's paying attention. Okay, so anyway, so here's the questions that you'll need to answer upon completion of this class. So the first one is, what does IoT stand for? Okay, it's an acronym. The other one is, how do I know that my cloud hosted system is safe and secure? Because that's typically the most important question that I receive, and I receive it over and over and over again about the security of our SCADA in the cloud, or things in the cloud, anything that has to do with the cloud for that matter. So anyway, so those are the two questions. What does IoT stand for, and how do I know that my connection is safe? So anyway, I'm going to go ahead and start first by introducing myself. Again, my name is Rick Patton. I represent Advanced Control Systems, and we're doing something a little different here now. And this is, like I said, my second try because I goofed up on the first one. And thank goodness you get do-overs, right? So anyway, we've got unique situation right now with the virus and everything, and so we're being asked to pre-record these presentations for the different associations that we work with. And so yeah, I've got a green screen. I hope you like my background, right? That's actually the little park that we have right by our office. So please, if you ever get a chance, we're at 2540 East Franklin Road in Meridian, Idaho. Okay, so we're not very far from St. Luke's. It's at the intersection of Franklin and Eagle. But we got a really nice little garden area. It's got chairs and stuff, and so we can come over and visit out there. But anyway, I kind of like having it behind me. It kind of gives me a little sense of serenity when I'm doing the presentation, which was kind of, I don't know. I'm actually pretty good at doing presentations. I'm just used to having an audience, I mean, I'd love to see all your faces right now, because I could tell if you're sleeping or not. I could also just get some feedback, as far as how I'm doing. So this is kind of a new experience for me. We at ACS are a systems integration firm. Okay, so really a controls engineering firm as well. So we do soup to nuts control systems control. So we do both industrial controls and we do municipal water and wastewater controls. We were established back in 1992, and so that makes us 28 years now. We've been in business. We've been right here in the Treasure Valley. So we're located, as I said, in Meridian, Idaho. And we started out with Micron being our one of our first customers, primary customers, as did many of the companies back then. Got their start with Micron, and it was fantastic for a long time. And we actually still have a number of people who've moved to different companies here in the Treasure Valley. We call the Boise area, surrounding area, the Treasure Valley. They've moved and started their own companies, moved to other companies, and so we've maintained those relationships. We don't actually do, any work for Micron anymore, because a lot of their manufacturing has moved out of the area, and then they also have in-house resources. So because that happened, as they grew, then it required an advanced control systems to diversify. And so that's when we started getting into the water and wastewater, municipal water and wastewater business. And so that was probably in the late 90s, I think. So we've been doing, municipal water and wastewater for over 20 years. So we have an electrical engineer on staff, so we can, do the design. We can, we have a computer-aided drafts person, so we can do the drawings. We can do the construction because we, are a UL listed shop, and so we're UL 508 listed, and then also UL 698, which is, the requirement for intrinsic safety, which is really important, for our wastewater jobs that we do, that we construct panels for. We also do the programming, of course, and that's really, our primary benefit, is because we've got an incredible level of expertise in programming. We have 5 pretty heavy hitters, 3 really heavy hitters that are, got 30 years experience in programming, and then a number of younger junior people who are coming up really fast and being mentored by our senior people. And then we also have just an incredible amount of internet systems architecture capability. So we have people, who are, because we have to, we're a SCADA services provider in the cloud. And so consequently, you have to have that level of expertise with regard to computers, computer administration, networking, all those kinds of things. And I think that's something that really sets us apart, as far as our skill sets, because I don't know that you find that at every systems integrator. So there's that. And anyway, so I'm thinking I've hit, pretty much all the bullets as far as advanced control systems. So I could go ahead and get started with the training. Okay. So anyway, so what I'm going to do is I'm going to share my screen now. Yeah, let's see, there we go. And I see it right there. Okay, so should be sharing the screen. I should be up in your upper right-hand corner. So I'll find out after I go back and review this when I'm finished. Okay. So again, this is the class is IoT in the cloud, and IoT stands for Internet of Things. Internet of Things. And we're going to talk about the Internet of Things, all the technologies that have to do with the Internet of Things, that allow the Internet of Things to exist, and how they impact not only municipal systems, but also, our daily lives, and what kinds of things that are coming. And it's pretty exciting, because we're not going to just talk about ACS and what we do, but also, the different technologies. So that'd be, where cellular is going, satellite communications technology, high-speed internet. Yeah, some stuff that I'm kind of a gearhead is the case. And so, I like it. So hopefully you will as well. Okay. So anyway, let's see if we can advance the slide. Okay, so yeah, so we're talking about internet in the cloud. So what is the cloud? Some people, the easiest thing might be just to say, hey, it's kind of analogous to the internet, really, because we've had the internet for a long time. But the difference between the internet and the cloud is that the internet we've used, to connect to things, to find things, to buy things, what have you. But until not terribly long ago, I'd say, probably about 2015 or so, then we didn't really have services on the internet. So, and there's an acronym for that. It's software as a service, SaaS. And because like about 2015, I think we still had like Best Buys. You could go down there and they'd have like several aisles of software, and you could actually purchase the software. You could hold it in your hand, take it home. You owned it, right? And So that's not the case anymore. Now, if you go to a Best Buy, you're not going to see software that you can actually purchase. It's all, in the cloud, and it's a software as a service. So you kind of, you pay as you go. It used to be, you just buy it, it's yours, you owned it, and that was it. And then that was all you paid until, it became incompatible for some reason and you had to replace it. But with the new services, then you have to pay a monthly reoccurring charge, or maybe you'll pay a reoccurring charge by the times that you use it. But reoccurring being the fundamental concept is that you're just going to pay as you go, as you use it. So that's a big difference, and it's getting to the point to where it's pretty much the case with everything. I know that some of you might use Windows. Well, Windows has become a service that resides in the cloud. QuickBooks, another service that resides in the cloud. Then you just you subscribe. You go and you subscribe, and you give them your credit card number, and then every month or every time that you access it, then you get there's a charge that's associated with it. We use the Google Suite, and it's fantastic, and it's really pretty affordable, to tell you the truth. I've been pretty happy about a lot of the software as a service kinds of products, because if you think about it, it really reduces their cost of doing business, because they don't have to package things, and they don't have to keep inventory in a warehouse, and so the vehicle that they get it to you through is the internet, and so there's a lot of expense, a lot of cost that's reduced, and so I think that it ends up benefiting both the customer as well as the provider. And that's what we like to think about, the advanced control system solution for SCADA in the cloud. Okay. Anyway, yeah, so you can have, your server is going to be located offsite. So, in the past, historically, traditional SCADA systems, then you would own the equipment, all the equipment, and it might be under warranty for a year. But then at the end of the year, you're responsible, and so then you've got, if you have to maintain compatibility between your computer and the software and all of the devices it's connected to. You have to provide maintenance to that, and so that means that you have to have internal resources that are able to do those kinds of things. And in the case of rural cities, it's not always possible. And so what happens then is like, well, then, you have to have somebody come from, in some cases, a long distance to come and do repairs or upgrades or maintenance. And it's very costly because of trip charges. So, the cloud, having that in the cloud and having it being maintained for a low monthly reoccurring cost, could be very advantageous for a number of reasons. Anyway, so you have a server offsite in the cloud. It could be a single server, multiple servers. These they're referred to as data warehouses. And there's a number of companies. I mean, a very, very long list. A couple of names that you might recognize would be Amazon, eBay would be another one. In addition to their shopping services, then they also sell the services of warehousing data and hosting your service. And that's what our company is doing as well. We have outsourced the support and the hosting of our services. So it doesn't even reside at our offices. It resides, maybe in Prineville, because Prineville, there's a number of physical storage systems over there. It could be in, a variety of different places all across the country, possibly even in other countries. One of the reasons that it's good, to have a data warehouser maintain and keep all that data and information is because That's their business. That's what they do. They are the best at it, even though our company is very, very good, probably the best in the region, from a security perspective, and as far as a network administration knowledge and capability. These guys are even better, and that's because that's all they do. Their whole value proposition is that we're going to keep your data safe, secure. It's going to be backed up, and it's seamless. So that if there was an earthquake at a facility in California, then it would automatically switch over to another facility, say in Louisiana or something. And then if that place, had some sort of catastrophe or disaster, then it would switch somewhere else. And so these companies, are much better equipped, and that also provides better continuity of service. So you're not going to have as many issues like with power outages or disconnects, between, like, say, for example, our servers, if we had them here, and our local service provider. And we've had some issues with that. It's actually been very seldom, even in that context, but it's actually going to be 10 times better at least now that we're moving it out to a third party. And we can get into it. We can do all the maintenance, and make all the changes and support our customers through it, even though the actual hardware doesn't reside at ACS headquarters. So that's pretty cool. You rent server space from a cloud hosting service. All clients connect to the server through the internet. Okay, and HTTPS protocols are used to connect to the server. And the reason I put that last bullet in is that it's real important when you're using your browser to look at the URL up in the window of the browser where you type in, whatever your search words are or what have you. That when you come to a site that has the HTTPS, includes the S because S stands for secure. If you just have an HTTP site, it's not secure and there's risk associated with it. So I just want to make mention of that. I'm going to get a quick drink. Okay, so SCADA systems in the cloud. I think we talked about the SCADA application being installed in the cloud. Ours is, we call it Carefree SCADA because it's carefree, because everything is in the cloud. We're taking care of it for that low monthly recurring cost, and you don't have to worry about it, and it's obsolescence proof. That's the other thing about these cloud hosted services, is that that's one of the first and foremost, is that they're obsolescence proof, and continually being maintained and continuous upgrades taking place. Pretty much instant problem resolution in a lot of cases, just due to the fact that we can get on it so quickly and get things handled so easily, because it's in a centralized location, and it's totally accessible to us to be able to, but secure as far as anybody else getting in. We'll talk about that some more in a little bit. So in this depiction, you can see the PLC. That stands for Programmable Logic Controller. SCADA stands for Supervisory Control and Data Acquisition. So I want to make sure that you know what those two acronyms mean. So the PLC transmits and receives between the cloud-hosted server and itself. And then also the desktop clients transmit and receive between the cloud-hosted server and themselves. And so consequently, we have a full circle communication between all devices in both directions. And it's really just basically it's instantaneous, how quickly things happen with the speeds of connectivity that we have. Okay, so let's go to the next. Okay, so yeah, so Wikipedia states that experts estimate that the IoT will consist of almost 5 billion objects by 2020, which, you know, happens to be this year. I mean, or 50 billion. I think I might have said 50 billion. I mean, that's just you know, hard to grasp, hard number for me to grasp. You know, but and it's growing, you know, exponentially. And it's just it's only limited by, you know, the imagination of the people who are inventing these things and inventing these services. I mean, you know, when you can have all these things connected to servers up in the cloud, you know, they're just there isn't much you can't do, to tell you the truth. It's a really a pretty exciting time to be in automation, that's for sure. And I'm excited to be part of what we're doing at ACS, because I think that our company is really unique in the fact that we are on the leading edge of these technologies. So it's pretty fun. It's pretty fun. I like it. So let's go to the next slide. So then the next thing to talk about is cellular. You know, so when we first rolled out our SCADA in the cloud, then at that time it was 3G, and so, you know, we had data speeds like, oh, I think it was download speeds were typically in the neighborhood of about 30 megabits per second, and upload speeds were in the neighborhood of about, you know, 10 or so, which was more than enough for what we needed to do. So that was one of the enabling factors, you know, for us to be able to provide these types of services. And the speed's just gotten faster and faster as time has gone on. So, but speed has never been an issue for the SCADA services, but it can be an issue, you know, if everybody's streaming at the same time. Just to give you an example, in McCall, Idaho, which is just a very beautiful place that we have over here in Idaho. It's a tourist destination. In the summertime, it just gets saturated because of all the people, and so they've had like 3 cell towers up there, and they're getting hit so hard by all the users, that they have difficulties with them bogging down. Last summer, they got to the point to where they couldn't even use their cell phones. It was so bad, but they've been making some improvements up there. I think that, to a great extent, that's what this technology is intended to overcome. That's the issue that this technology is intended to overcome, because instead of having just a few really large cell towers, these are going to be, you know, a lot more. There's going to be a lot more quantity of them in a commerce area. So, you know, like say, for example, a city, you know, then you'd have, you know, many of these little mini towers, I guess as you could call them. I actually have one. Is interesting. Right when I was developing this training, I noticed that they had just put one of these up in Boise, little old Boise, Idaho. I happen to live right off of State Street, downtown Boise. I'm only like 9 blocks from the Capitol, and my backyard faces that street, and I can see you know, there's actually an intersection behind my house, and so I could see the light poles, and they put up on the light pole one of these, and and it was right by Starbucks, of course, you know, got to have high-speed internet next to Starbucks. But I think that what they're doing is they're just making it to where they can, you know, support more users, multiple users, and not bog down the system. The 5G is really kind of apples and oranges with 4G. 4G is sticking around, so, you know, don't worry about your 4G devices, because we have a bunch of cell modems out there that operate on 4G. And I've talked to Verizon, and what they've told me is that the 4G is really intended for a completely different requirement. It's really for, you know, kind of the long range, long distance, remote areas versus these smaller little towers, little pods, if you want to call them that, really more for commerce areas, so medium, large cities, possibly even small cities though. And you just have fewer of them depending on the size of the city. But yeah, they're saying that they could be 100 times faster than 4G. Like I said, we already have more than enough bandwidth, to support the services that ACS provides. So here's a nice depiction of a city with multiple towers. As you move from one location to another, all the towers automatically recognize your location, and then your mobile device will just switch from tower to tower automatically. And so it's completely transparent, and you just feel, the impression is that you just have ubiquitous, continuous coverage wherever you go, even though it's actually switching between towers. So anyway, what did I have here? The satellite network will be developed from the get-go, from the very beginning, I suppose that's my own terminology, to interoperate with a 5G architecture. So they're bringing in satellite. I think I got my cart before the horse here. So satellite's going to be, an integral part of the 5G system. So 5G systems are being deployed right now, have been deployed throughout the course of 2020, and the satellite interaction or integration between them and the high-speed communications, that's already been defined. So these are going to be used in conjunction with satellites. So speaking of satellites, I would imagine some of you may have heard of a fellow by the name of Elon Musk. And he is a very interesting fellow, very, very wealthy, very, very brilliant, and quite a unique individual in that, from what I've read, his primary goal is to fly to Mars. Yeah, the guy has high aspirations. He wants to fly to Mars. But anyway, but he also has created some pretty amazing companies. Probably heard of Tesla, the electric car company. And I never really thought for the longest time that the electric cars would really ever, be feasible. And to a great extent, he's made them feasible, and not only feasible, but desirable. So I take my hat off to him with respect to that. I think that's pretty cool. I may even own one. I'm a motorcyclist, and I've actually been considered buying an electric motorcycle. There's, and of course I'm kind of a gearhead too, so that might explain that interest that I have. But anyway, but he also has a company called SpaceX, and so this is a company that is providing delivery services to take equipment into the what's the word I want to say, low orbits. They call them low Earth orbits. So that's an acronym, LEO, and they call it LEO for short, low Earth orbits. So he's helping companies and himself to deploy equipment, systems, satellites into low Earth orbits. And so he has a company to do that, but there are other competitors, Virgin Group, Boeing, Amazon, LeoSat Enterprises, but SpaceX has been just phenomenal and amazing to my belief. And they have had, at least very few failures that have been really publicized, but they've seemed very, very successful, and possibly, more so even than NASA, so maybe it's a good idea to privatize this now. And I know they're working in conjunction with NASA on a number of projects, but Starlink is another company that Elon Musk has launched, and so this is the idea of having a satellite constellation, and basically it's just a great big mesh of satellites that's in low Earth orbit all around the perimeter of the globe, and the idea being that it will provide high-speed internet connections to any point on the face of the planet. So, so for the rural community, this could mean some changes. A lot of changes are going to occur as a result of having high-speed connectivity. You know, with the virus and the emphasis now on home learning and you know, social distancing and people, you know, wanting to work from home. You know, and I personally, I believe that this virus it's a temporary situation. You know, historically, you know, these things have been handled, and we've built up immunity to everything so far. You know, pretty much. But you know, there could be other viruses, and I think there's this really heightened awareness now, and so consequently, there's a big push, you know, at the United States federal level to have connectivity to rural communities, so that, you know, you can distance learn and things like that. Well, one of the reasons people like to live in you know, rural places, you know, is because there's fewer people and it's quieter, and you know, and being in the city isn't as desirable as it used to be for a lot of people. And so I think that there's maybe kind of a shift that's starting to occur where, you know, people in the metropolitan areas and things are thinking about, you know, moving out and being, you know, more distant. So, and this kind of technology could cause them to consider places that they hadn't considered before as places for their residents. So, just letting you know. But the good news is that it also brings services to these rural areas that they'd never had before, and also, you know, reduces the cost in addition to that. So anyway, I'm kind of going on a little bit of a tangent there. But yeah, commercial operation could start in 2020. It's already begun. And I was reading the other day that they were doing speed tests with the satellites already. And right now they're clocking in anywhere between 35 and 90 megabits per second download speed. And they're doing somewhere in the neighborhood of about 10 to, I think it was 30 or 10 to 15, yeah, 10 to 15 megabits per second upload speed, which is pretty respectable. I mean, one of the things that is different about satellites has always been delay, you know, because you got so much further, you know, for that signal to go before it bounces off satellite, goes back to where it's intended to go. And so those delays, you know, will cause you know, delay in your experience and the user experience. And they've been able to figure out ways. I don't know if it's like the frequencies that they transmit or what, but they've got it down to, I think it's like a tenth of a second, you know, as far as how long it takes for it to get from point A to point B. And it's not perceivable. They've got it to the point where it's not perceivable, but that's part of the reason why they have maybe not as high of a bandwidth as, say, like, for example, you know, cable or, you know, or fiber or something like that, because they have such a long distance to travel. But anyway, but still, you know, if you're somebody out, you know, like say in Antarctica, you know, like 50 megs down and 10 megs up, you know, that might not seem too bad. You could certainly be streaming Netflix at that rate. So, okay, Starlink. Okay, so we could pack 60 satellites in the nose of a rocket. This is a Falcon 9 rocket, and they're putting 60 of those satellites in there. They're about the size of a folding table, and they each weigh in the neighborhood of about 500 pounds. So if you take 60, you multiply that by 500, you got 30,000 pounds. So that's quite a payload, quite a payload. And they're shooting 60 of those things up about every month, sometimes twice a month now. Actually, Starlink had to get an agreement with the Federal Communications Commission, and I don't really understand why they imposed this, but the federal government said that they had to have, in order for them to be able to do this and to be able to deploy these satellites, they had to commit that they would have 12,000 of them in orbit by 2035. 12,000. That's a lot of stuff in a low Earth orbit, sorry. And all of that's in the same orbit, you know. I mean, I don't know if they may be able to interleave them a little bit, but that's a lot of stuff flying around out there. The other thing that's causing is some unhappiness with astronomy, you know, because these things reflect light. So so it's goofing up, you know, they're stargazing, and you know, but they're trying to figure out ways to use paints and you know, surface conditioning on these satellites so that they aren't so reflective, and so that they don't you know, cause so much trouble for people who are, you know, interested in gazing at the stars. So there's all kinds of, you know, it's interesting and controversial. But anyway, so that's how they're getting them out there. So anyway, so I've got a video that I'd like to let you see, and it's called Starlink Blast Off. So let's give that a try, see how it goes. Okay, I gotta start it over again. Apologize.
6, 5, 4, 3, 2, 1, 0. Ignition, liftoff. From Starlink to Falcon, Spaceport's inaugural launch. Vehicle is pitching down range.
We are T plus 45 seconds into liftoff, and we have just had liftoff of our Falcon 9 vehicle carrying our Starlink payload. In just about 15 seconds from now, we will be passing through max Q. This is the largest aerodynamic pressure that the vehicle will see throughout ascent. And we've got an awesome view of liftoff right now.
Vehicle is passing through maximum dynamic pressure.
And we just heard that call out for passing through max Q. Now, coming up in about a minute will be a rapid succession of events: main engine cutoff, or what we call MECO, followed immediately by stage separation and SES1, which is second engine start. Now, MECO is where we shut down that main engine on the first stage booster to allow the vehicle to slow down just enough to separate from second stage. If you're just now joining us, we have an awesome onboard view of our vehicle, Falcon 9. And in about 30 seconds will be those three events: MECO, main engine cutoff, stage separation, and SES1. And there is MECO, as you saw those engines shut down.
Stage separation confirmed.
And there is stage separation and second engine start. You can see that second engine on your right screen glowing bright red. Now in about 20 seconds, we will have fairing deploy. And we should be able to see this on our screen as well. And on that left screen there, you can see the grid fins. It's a bit dark on the East Coast right now, so hard to see, but we did see those grid fins deploy.
Fairing separation confirmed.
And there is fairing deploy. So as Lauren mentioned earlier, we will be attempting to catch one of the fairing halves on our recovery vessel, Miss Tree, but we will not be able to show this live, so check in with our social media for updates.
Billions of years ago,
Okay, sorry.
our nearest planetary neighbor, Venus.
Kind of just runs right into the next one, so apologize for that. But anyway, okay. So, now Starlink has, and this was just as of probably about 2 weeks ago, I got the latest numbers, 586 satellites in orbit. And this picture is an example of what they're calling a satellite train, which is kind of obvious. It's kind of interesting. I was putting this class together back in February, and I went out, wasn't while I was putting the class together, but it was like one evening I went out and I looked up at the sky and I saw one of these trains, these satellite trains. It's like, oh my gosh, I know what that is, you know, because otherwise I would have just been befuddled. But yeah, it didn't look just like that. These are very, very close together. So this must have been just like immediately after they had been deployed. And I don't know if you noticed, but in that video that we just watched, when the nose cone was deployed, then that whole stack, you could see that whole stack was all satellites in the nose cone. But when they first come out, you know, they're very, very close together, and they have to be for the deployment to take place properly. But then they actually have built-in propulsion systems that allow them to navigate and move away from each other and into their respective orbits. And so they're going to just stay, you know, stationary. Once they're in their final destination, they just stay stationary, and then of course the Earth rotates inside of that sphere, you know, the sphere of satellites in the low Earth orbit. But yeah, pretty amazing. So this is an artist's rendition of the satellite sphere, or the matrix or web of satellites, you know, for high-speed internet communications. And I've got another video, which this one is about artificial intelligence, which I thought was pretty interesting. And because if you have all of these things, you know, Internet of Things out there, they're all connected back to servers in the cloud, and they're accumulating all this information. Then just think what you can do with an intelligent host that can change things as a result of the inputs that it's receiving. Okay, that could be intriguing and also kind of frightening. But anyway, let's take a look at this video, and I hope you enjoy it.
We're surrounded by the Internet of Things. Thousands of sensors relaying data from cars, factories, and stores. These sensors and the data they produce ensure safe driving, food safety, and efficient production. However, there is much more we can do with the large amounts of information that is generated. At IBM Research, we're developing AI technologies to connect and understand data in ways never seen before. We combine machine learning with knowledge graph reasoning to enhance the data with layers of semantic abstraction. This gives us new, natural user interfaces that allow us to gain new insights from the data.
A lot of the data that's coming from us is IoT based, and that's Internet of Things based. So that's machine to machine data. When you get a lot of data thrown at you, it ends up being a very difficult task of trying to extract real insight from that data set. The only way we're going to solve this problem is to teach the machines to make sense of the data so we can ask it questions and expect reasonable answers.
We developed a knowledge graph for IoT. The system knows all about IoT and understands the meaning of different types of data. It works in a similar way to the way our brains think. Imagine a temperature sensor in a building. An office worker tells the system, "Hey, it's too hot in here." It analyzes the speech as text and extracts the concepts hot and here. It understands that hot is a concept for heat. It quickly accesses the knowledge graph to find all assets in the area. It then uses AI analytics and sensor data to determine if the temperature is actually too high. It realizes the office area is located close to a window. It checks the illumination sensor, automatic blinds and weather to see if there is high sunlight causing excessive temperature and finds nothing unusual. It tries a different branch in its knowledge graph. It finds an AC unit and uses AI diagnostics to find that the heating valve switched on. So it can actually identify the problem and then commission work automatically to the relevant people to go and fix that problem.
It is a scalable solution that enables IoT to learn behavior, to understand operation, and to self-diagnose problems while making human-machine interaction more natural and intuitive.
It's a general-purpose, artificially intelligent, multidimensional knowledge graph for IoT. It combines reasoning with machine learning to analyze and understand very large data sets in real time. This enables new insight on complex systems at scale.
Okay. So, hope you enjoyed that. So this is just kind of list of categories for different kinds of things that can be connected with the cloud. And it's just, you know, very, very truncated. There's so many, it's more than I can even comprehend. And more all the time. Like I said before, you know, 50 billion things by 2020, and it's like it's growing exponentially. But these are just things that you can imagine. Say, for example, in the home, then you know, I know that there are devices that can help you to monitor and control the temperature of your home, the drapes, the blinds, whether they're open, closed. All of your appliances, you know, refrigerators, all kinds of things. I also, of course, you know, you have your Echo Dots, right? Your personal assistants. It just goes on and on and on and on. So anyway, the potential is just staggering. You know, as far as all the marketing opportunities, and ACS is trying to capitalize on that within, you know, just the space that we occupy, which is systems, controls, and monitoring. So promise of IoT, and this is something I found, it's actually, I found it on the internet, this statement, but that the promise of IoT is to improve the ease, productivity, health, safety, and involvement in human life experience. And I was a little sarcastic about that statement, but I mean, I think it's fantastic, and it actually has improved my life. I mean, you know, it's real silly. I've got these video surveillance systems because, as I mentioned, you know, I live in downtown Boise, right by a very busy street, very busy intersection. And I put these cameras on my house and at the doors and the garage doors, so on and so forth. And so anytime, you know, they are activated, you know, by movement, then my phone has a little doorbell, and ding dong, you know, here's the ding dong. And you know, sometimes it's distracting, you know, because I might be in the middle of doing something important and I hear that, you know, and I just want to look, pick it up. But it's been really nice though, because I get this feeling of serenity, just knowing that everything's okay at the house. And I see my wife actually works out of the home, so I get to see her coming and going, and I get to see, if like my packages are arriving, so I mean, I'm just giving you one example of how it's definitely been a benefit, for me in my life. I also use the Echo Dots and Amazon Music and things, so there are all kinds of things, that could be a benefit. But then on the flip side, I was thinking, man, it just reminds me that we had mandatory reading, when I was in grade school. The book is called 1984, and it was written by George Orwell. And this fellow was just somebody who was way ahead of his time. I think this book was written in, like about 1940 or something like that. And he writes about this utopian society that is under complete control and surveillance by the government. And so they have all these cameras, and they're keeping track of everybody. And so that's kind of one of the things that comes to mind, with all the cameras that are going in everywhere, and surveillance systems and high-speed data acquisition and information going to the cloud and artificial intelligence. It's like we're living in a sci-fi movie. And speaking of sci-fi, then you get to the second one, 2001 Space Odyssey. Then that's about a computer that is controlling a spacecraft, and then so there's a human in the spacecraft with this computer, and the human is supposed to have the final say, but the computer starts getting more powerful than they had intended or expected, and so that's kind of interesting as well. So those were the two things that kind of came to my mind, when I was putting this class together, and so I thought you might enjoy that. So, okay, how does IoT in the cloud help the wastewater operator? Well, you probably thought I'd never tell you. What is it? What can it do? What is its limitations, advantages? How do you connect, and how secure is your connection? So I'm really excited. We came out in 2012 with our Carefree SCADA in the cloud, and we've had that out now for 8 years, and we've got probably about 30 customers. They range anywhere from a small subdivision to cities, in the neighborhood of about 15,000 people population. And so it's come a long way, and we have started to expand our services to provide other more low-cost options, because the one that we first came out with, is kind of the Cadillac. And even though it actually is less expensive than what I refer to as traditional SCADA, where it's traditional as you own your own computer and you own the software, and you have to maintain it, versus, in our case, then, the computer's in the cloud, software's in the cloud, we maintain it. That was kind of the fully accessorized solution, and we've been doing really well with that, and it's been received positively. But we thought there was a number of situations we encountered where it was considered to be too costly, and so we've been trying to bring the price down. And so we have what we call our Carefree Lite, which is kind of like, the next step down, and then the Carefree IoT. And this was the device in this picture of this that we found. And I looked because I was looking for something. I mean, I'll just give you an example. In the southern part of Idaho, and of course, there's so many states now where water is becoming more and more of an issue. Having water rights and being able to exercise those water rights, and then the policing of those water rights. I'm just using this as an example. Then across the southern part of the state, then the Idaho Department of Water Resources, they have people who go out in their little pickup trucks and they take their little tablets with them and they go out and they read meters all over the southern part of the state. And so that was the first practical application that I came up with was, gosh, why, if we've got the ubiquitous cellular coverage all across the southern part of the state, why not put like a little device out there, it could be battery powered and have like a little solar cell, or something, to keep it going. But then just have that data instead of having people driving all over the place, using fuel and beating up their trucks and things. Just have one of these out there and have it send up to the cloud. And then, you take that data in the cloud and you organize it, however, in whatever way that the recipient wants to see it. And also be able to provide them with reports and so on and so forth, and it all be automated. So that was the first. And so I started really looking, but then we've been finding other applications, and we're finding that in the municipal, then people are looking for backup alarms, just a simple backup, just to ensure that, because if you're already using, like, say, cable for your connectivity, or you're using DSL for your connectivity, or you're using like a line of sight radios, then if you have another technology, like in this case cellular, then that is a alternate technology, doing the same thing, being utilized for backup. So if you lose your radio and you lose communications and something happens, then this guy can come back behind it and make you aware that there's a problem. Okay, but there's so much more that this little guy can do. But it is an IoT. It would be a great example of an IoT device. It also is cellular, right? Because I'd mentioned, if you had something that was cellular, so it has a cellular SIM card in it, and so we actually work with a brokerage firm, and this brokerage firm, what they do is they sell communication services, and they're a brokerage firm for like Verizon, AT&T, Sprint, so basically whichever service that you're using, we can support through our brokerage service provider. And so it's really slick, because then you don't have to deal with the service provider. It's everything is handled by our company, and so ergo the name Carefree, right? So you don't have to worry about it. We take care of it for you. That's just an example of a very, very simple screen that you might see. I'm sure that many of you probably have SCADA screens that are a lot more sophisticated than this, but this is intended to be simple because it just has only one purpose. This little device, it only has, like 3 inputs and outputs, and so it can't, it can only really be used, to monitor situations and provide alarms. Okay, so in order to give you a visual rendition, it's going to be pretty simple because it doesn't do a lot of things. But what it does do, I think, is really important. We're finding that with as I do this conference, not this conference, but this training at conferences, I get just an incredible amount of response from the audience and questions at the end, because people are coming up to me and they're saying, oh my gosh, this is, really simple, inexpensive, and that's just what we want. So what are the limitations? Well, it has limited inputs and outputs, as I mentioned. It's not expandable. You can't like add another, card to it or anything like that. It's just, it is what it is. Limited customizations on the, on the interface. Basically, the most basic version of this thing, just gives you an alarm, like a text alarm on your cell phone, and the ability to acknowledge that alarm. But even with, we have a couple of flavors of it that have additional costs. You're still, just getting really, really basic reports, if any, just a very, very simple report. If you want some kind of a report to tell you about data that's being acquired, like, remember I was mentioning the flow meters, measuring flow for the Idaho Department of Water Resources. Oops, sorry. Apologize for that. You can't remember everything, when you try to prepare for these classes. So I'll have to put that one on the list. But anyway, so so if you're bringing in an analog signal and you're wanting to monitor values, over time, then it's very, very rudimentary. But still, it's also much lower cost. And there's no way to change the logic in it or anything. I mean, it's basically they're monitoring something that's happening out there, tells you if it happens or not. Or you might be able to send a signal to tell something to turn on or to turn off, but that's about it. But in so many cases, that's all that's necessary. So it serves a purpose. So the advantages are it's inexpensive. On this device that I found, I didn't actually find it, it was one of my colleagues here. It's the inputs can be either input or output, or like discrete. So that it could either be an input or an output. I'm sorry, I'm getting confused. It could either be an input or output. So it's like configurable. Like you get the software, you hook up to this thing, and you could tell it, okay, you're an input, or you could tell it, oh, you're an output. And then you could say, oh, okay, you're discrete. Discrete means it's like a switch, on or off. Or there's the phone again. Or it could be analog, right? And so that's kind of neat. It makes that little device a lot more useful. And then it could be customer installable. So, we might just put this in a box and send it to you, and you can install it, or if you have an electrician, they can install it, save money, instead of having us come out, because, we're going to have, maybe a higher cost of labor, and then the distance that we have to travel. And then we can actually remotely access it, so once we get the thing online and we're connected into it through the internet and the cloud, then we can, do firmware version upgrades and things like that, and we're still, I need to become more familiar with it, because this is just like, right off the presses, we just bringing this out. So we're still learning a few things about it. Is your cloud connection secure? It is and it isn't. I mean, I'll tell you, it's as secure as it can be if you're having us administer it, because we're actually certified with the Department of Homeland Security. We got 3 guys that have gone through the training and are certified and maintaining their certification. And then we're also using secure socket licenses. So on the customer's end, then you have a secure socket license, and on our end, there's a secure socket license. These 2 guys are the only guys that, it's like a key. They're the only guys that know about the other, and so that means that you have a secure connection. Once that secure connection is created, then you have encryption, data encryption, and we're using 256-bit encryption, which is what's being used by National Security Agency, by the federal government, and being used by the military now. Because the military, that's the thing that's ironic, is that when I first started peddling this stuff, if you will, then people are saying, oh well, Department of Homeland Security says you can't connect your SCADA system to to the internet. Well, guess what? Now our Department of Defense is actually putting their information up in the cloud. And maybe some of you have heard, in the news that there's some contention between Amazon and Microsoft. I think what ended up happening is that Microsoft ended up getting the contract, and Amazon was pretty ticked off. And so now then Amazon was, filing lawsuits against the federal government. And, it was just a big mess. But yeah, the federal government is now saying that, hey, we're confident in it enough that we're willing to put our military information you know, I mean, top secret, you know, information in the cloud. Okay, so they must have a fairly high degree of confidence in it. But we're using the same, you know, secure measures as they are, and we have exceptional expertise. Anyway, so that is the end of the training. I'm gonna go ahead and stop sharing the screen, and then so I'll get back on here again. So I just want to just tell everybody thank you so much for spending some time listening to this and watching this, and I had a lot more fun with this one than I did with the one I did this morning. But I'm really excited about this new technology with being able to pre-record and give you guys an opportunity to still get your CEUs, even though we're not able to always go to the conferences. I'm really, it's a shame that, you know, we're not able to get together and hang out. You know, that's definitely my preference. But I think I'm sitting at about probably 50 minutes on this, so I'm thinking that there will hopefully be about 10 minutes left for some questions. I've been asked to be on the phone or in the meeting actually, so that at the end, you know, if you have any questions, you can ask them of me now, you know. But again, you know, thank you for watching.